All right. Hey, everyone. My name is Nick Brady. I'm the CTO at Natrx. It's a local company here in Raleigh. So the core of our business is actually creating living shorelines. It's a niche of kind of shoreline revetments where you protect shorelines from erosion. And we also create artificial habitat, think reefs and stuff like that. So my background in schooling is mechanical engineering, and then I became software engineer, and then I found myself doing GIS here at Natrx. So what that started when we needed to support our core business because part of doing shoreline revetments is knowing where to actually do the shoreline revetment in the first place, especially when we're looking at large scales. There's for a lot of our work, for example, is in South Louisiana, and the marsh complexes are massive. There's always limited budgets. And so a very practical question is where are the kind of peak erosion spots intersecting with the infrastructure we need to protect, and where do we best utilize our funds to create like a capitalized plan to protect, our infrastructure going forward. So we put in a proposal to NSF and were awarded a SPAR to build a tool set and infrastructure to help answer these questions. Um, like I said, I didn't know anything about GIS. I found grass Googling. These are the days before LLMs, unfortunately. I wish I had that. But these are the primary reasons I chose to go with grass GIS. I knew I needed to use machine learning and I wanted to use object-based image analysis. And grass GIS provided me the tools to do that based on segmenting zone statistics, algebraic operations for calculating erosion, like with diffs, whatnot, that I needed as kind of inputs. And then furthermore, it also provided me protection for things I didn't know about yet, just because there's such a large number of modules. And finally, the documentation is really, really good. So I've experienced a lot of pain from poorly documented projects in the past, and it was very refreshing to see how well documented every single GraphGIS module is and how consistent it is to jump from one module to another. So that was massive for me. So what we do is an area-based analysis technique for erosion. There's a lot of different techniques. You can do transects. There's, so many of them, but we primarily focus on marsh ecosystems, and they're characterized by very complex shorelines. And so area-based techniques make a lot of sense. To summarize it relatively simplistically, we find a shoreline, we draw polygons along that shoreline, and then using diffs from that start reference period looking backwards, we kind of look at a trend of pixels disappearing within that area, and we do a linear regression through it. So it's standard, simple in concept. GraphGIS makes it pretty easy to do in application. And then I'd say the other challenge to doing this is largely more process based at the application layer. So this is a simplified architecture for how we did this. Very, very typical client server web application. And then we did the processing management we chose Airflow, and we integrated Grass with our Airflow workers to distribute this out and manage the different processes that actually did the work. So this worked really well. GraphGIS is a file system based database, so we had to have a mounted directory to all of our workers in order to do this. I chose EFS, an NFS server, on-prem would have been just fine or whatever else, but EFS did work very well because it just scales automatically. You don't have to think about it. So worked well for me and it worked. So this is a project that we did last year. We've done a few since, some bigger, and it's continued to work. But this is Guyana in South America. So the shoreline is about 600 kilometers. And we processed this in 17 sub-projects. Each of those had 60 images. We're using Planet imagery at 5 meters. And we could process and rerun results really quickly. I mean, in general, I realized I overbuilt this thing, and I could have done more homework before I actually built the thing. But yeah, it worked well. So, and that's getting into this final point, which is, I started building this massive platform, and then I was like, you know what? I probably could have just bought a computer, a very nice computer, and put this thing on there instead, and it would have saved me a lot of time. So focusing on CPU parallelization as opposed to going to a distributed environment like I was used to with more of a web background and scaling servers in a more classical fashion was something new to me. And if I was when we've actually already gone back, but yeah, good learning lessons. So either way, we built this tool. It provided a ton of value to us, and we continue to deliver projects to clients around the world.